Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to create an endless runner inside of Godot. So we're going to go through the basic process of spawning objects, having them come to you. We're going to talk about how to do left and right and segment out your level into lanes so that way you can bounce from lane to lane. We're going to talk about how to do pickupable objects like coins, which will give you extra score and extra things like that. Then we're going to jump in and we're going to talk about how to create a leaderboard and how to handle that. We're going to talk about how to create a basic game loop, so when you die, how to respawn and handle all of that. And finally, we're going to talk about how to save and load your leaderboard so that you have persistent game data. So that's what I have in store for you guys today. Let's go ahead and get started. All right, so the first thing we need to do is we need to build out our scene. So in order to build out our scene, we're going to need to come in here and create a new 3D scene. Since we're making an endless runner, we want to make sure that we have our player. We want to make sure we have kind of like an environment of some description, and probably a way for us to spawn in objects to have them fly at us for us to be able to dodge. So what we'll do is we'll come in here. We're going to rename this as Game Manager, like that. We'll right click, add a child node, and let's add in a character body 3D. We'll name this Player. Now we're going to be building a very basic Subway Surfers-esque game, so you'll have coins and things like that. But you need a player to be able to actually start with any of that, right? Now, when we do our player, we need a way so we don't fall through the world. So we'll right click, add a child node. We'll add in a collision shape 3D, and that's basically going to allow us to not fall through the world. And we need a way to visualize our player. So I'm also going to right click, add another child node, and I'm going to add in a node 3D. I'm going to call this model. And the reason why is because that's going to make it easier for us to animate later when we need to. And I'm going to right click, add in a child node, and I will add in a CSG cylinder like so. And I will make it about this big. That's fine. And I will pull it up so that way we actually have it at the bottom of our little screen here. And that means I'm going to need to pull my collision shape up so it actually matches as well, because you want your collision shape to match your actual model as much as you can. Now I'm going to drag this down a tiny bit, and you'll notice that my collision shape is a little bit bigger than my actual CSG cylinder. Don't worry about that. That will get fixed in a little bit. I'm also going to make this just a touch smaller. There we go. And then I'm going to right click, add a child node, and I will add in a CSG sphere as well. I'm going to drag that up, and we'll make it nice and small, so that way we got kind of like a little head almost for our little character. And I'll actually adjust his body size to be a tiny bit smaller. There we go. And he's got a pretty large head, but I think that will work out. Now, of course, you can do whatever you want. If you have your own character model or animations or things like that, now would be the time to kind of put it in and make it work. Now, once we have that, we have some collision. We're not going to fall through the world. So I will save, and I will just call this main.tscn. That's going to be our main scene. So when we hit play, we'll have that as our main scene. Now, if we go into our game, we right click, add a child node, and add in a node 3D, we can call this environment. Now you'll notice that I have my player and my environment, and I'm separating the two. And the reason why I'm doing this is going to make it a lot easier for us to be able to distinguish where things are at inside of our tree hierarchy. So since Godot organizes everything as a tree, if you put your player and your environment and you separate the two, it makes it a lot easier to work with in the future if your project ever gets larger than just a small hobbyist project. So that's something to keep in mind. Now I'm going to right click, add another child node. And for my environment, I'm going to add in a static body 3D. And then I will right click, add in another child node. I'm going to add in a CSG box. And I'm going to make this however big I want my actual mesh to be. Now you could do a CSG mesh, and that's totally fine, But in my case, I'm just going to go with this here. I'm going to go with a 10, and I'll go with 0.5, and I will go with 200. Now, that's going to make a gigantic runway, you'll see right here. And basically, that will allow me to have my entire running space. Because the idea is that the stuff is going to spawn down here, and it's going to come down towards us. We can kind of pull this up like so. And there we go. So now if you look out, you'll see it's just going to be a really long distance. And basically things will appear in front of us here and they'll come down to us. So they'll actually come down, and that will basically be how it will work. Now, I'm also going to just preemptively set up some collision here. So we'll right click, add in a child node, and we'll add in a collision shape 3D. And we're going to make that into a new box shape. Now, technically, I know CSG meshes have their own collision. So technically, you wouldn't need to do this if you don't want to. But I like to do it this way. I like static bodies to be done this way. That being said, if you prefer, you can just come in here, click on your CSG mesh, use collision, and you probably don't even need this static. You probably could get away with doing something like this, and then deleting that. And that technically, I believe, would work. So if we hit play, well, we're not going to see anything because our player doesn't actually have a camera. So let's add that. So we'll add in a camera really quick, and we'll kind of bring this guy back, and we'll rotate it down like so. So if we click preview, you'll see this is what we're going to see. So if I hit play now, you should see this. And right now, it's not really doing very much, right? Well, we don't really see much here because our scene has no lighting. And also, you'll notice that we're not really doing anything. And that's because our player has no script, so he doesn't know what to do yet. So what can we do about that? Well, first, we can add in directional lighting. If we come in here, we can adjust how our lighting is going to look. So you can see how it looks right now. If you wanted to change how the lighting looks, you can go ahead and do that in here. And once you're happy with it, so whatever you decide is best for you, go ahead and do that. So I'm going to put this somewhere in that direction, because that way I get a nice little shadow right here. That just kind of makes it look a little bit nicer. Then I'll hit add sun to sky, or add sun to scene, and then add environment to scene. But I'm also going to click AO to give myself a little bit of AO here. And that just kind of helps darken in these edges, makes it look a little bit better. And now if I hit play, you'll notice that if I select my current scene, that I can now see everything, and it looks like a reasonable game, right? It's a good starting point for our game. Now you'll notice that once again, we have no control over our player, and they're not really doing anything. So in order to actually get stuff to work, we need to code it all in to work. So what that means is that we need to actually right click on our player and attach a script. And I'm going to call that player.gd. So in order to make our endless runner, we need to come in here and make a bunch of changes. So first things first, we need to be able to make it so that our player can switch between lanes. So in order to do that, what I'm going to do is I'm going to come up with an enum that's going to basically hold on to that information. So an enum is basically like a state or a value that you have a word that's associated to, like a number, if that makes sense. So for instance, enum lane, and I'm going to say left. We're going to make that equal to 1, comma, center. We're going to make that equal to 0, and we're going to make right, and we're going to make that equal to -1. And basically, this will allow us to have a number, or I guess a word that's associated with these values here. It's just going to be a bit easier for us to debug. Now, technically, you could just go with 1, 0, and -1 if you wanted to. But in my case, I wanted to make it a bit easier for us to understand it. And also, I'm going to do the same thing, but with states. I'm going to create a state machine so that our player can be in different states. So that way, it'll just keep our code a little bit cleaner. So I'm going to go with enum state, and I'm going to have running, jumping, sliding, and dead. And that basically will allow us to have some states to work with. Now I'm going to export out this var here for speed. I'm going to change this to speed for lowercase s, and I'll make it a 10 instead of a 5. Instead of a const, I'm going to say at export var speed, because I want to give us the ability to change that value. And same thing with jump velocity here. I'm just going to copy this. I'm going to paste it. I'm going to say jump velocity like that. And I'll just grab this guy and paste it in here. Now you'll notice that speed is also capitalized down here. So I'm going to grab these guys and get rid of this stuff here. Now, that being said, this is probably not necessary here. We're probably going to have to delete this out anyway, but it's just good to keep your code compilable. Since Godot is a interpreted language, you can't just go and refactor your code and have it show IntelliSense. So a lot of times it's good to just make your stuff compilable and then use IntelliSense to kind of find out where you're at. So from here, we're going to need to keep track of what lane we're going to be in. So I'll come down here and say var target lane, and I'm going to make that into a int, and I will default that to lane center like that. And then I will have another one, and I'm going to call it my current lane. So we'll get rid of this section here, current lane, and we'll say lane center. And that way we have, like I said, a very easy way to understand what's going on. We are at lane center. The character is in the middle of the lane. Simple enough. So inside of our physics process, I'm going to come in here and basically delete all of this. I'll keep the gravity. I don't know if I'm going to want to keep the jump or not. I'm debating it, but I think I'll keep the jump just so that I have it. And since the obstacles are going to move at the player, we're going to basically burn all of this because none of that's actually really all that useful to us, which is a good thing. So we'll burn that, get rid of that. And what we're going to do is we're going to handle some of our lane movement. So in order to do lane movement, what we need to do is we need to come up with what our width of our lane is. So I'm going to export out a variable for that because we want to kind of know what our lane variables size can be. So I'm going to say at export lane width, and I'm going to make that equal to 2.0. And actually, really, if these are exported values, technically I would want them to be capital L. So I'll do a capital L here, and I'll probably do the same thing here, capital speed, capital jump. This is my convention. This is not official Godot convention, so please forgive me for that. But I prefer this way because it's more of C#-esque and it feels a bit easier for me to read. So that's the reason why I do it. It separates Godot code from my code, if that makes sense. Now, once we have this, I'll scroll down here and I will say var target x is equal to target lane multiplied by lane width. Okay, what that's going to do is that's going to segment our lanes up into 3 values. And then I'll say position dot x is equal to target x, like that. And then I will just come in here and I will do if input dot is action just pressed, and I will pass in the, if we take a look, they should have a UI left key like that. And then we'll say target lane plus equals 1 if input dot is action just press UI underscore right then target lane minus equals 1. Just like that. And now, if we come in here and we hit play, you'll see I can make my character go left and right. Now, it looks like it's backwards a little bit. So if I hit left key, my character goes to the right. And if I go right, my character goes to the left. So I might have some stuff backwards here. Or, of course, we could flip it if we wanted to. So what I'll do is I'll just come in here and say, if we scroll up, let's go with -1, +1, and then let's come in here and go minus, and let's go plus. That way we can just make things a little bit easier. So if we hit play, left, right, that's perfect. That's exactly what we wanted. Now you'll notice that the character kind of snaps to the different lanes. You can see left, right, like that. And you might not want that, right? You might want it to be a little bit smoother, a little bit nicer, a little bit easier to, or a little bit easier on the eyes, right? So how can we do that? Well, if you take a look here where we're setting our position right here, instead of doing just equal to X, what we could do is we can do a lerp. So we'll type lerp position.x comma target x, like that. And then we can set some kind of weight, some kind of speed. So what I like to do is I like to make it an exported variable. That way we can adjust it. So I will come in here and say lane change speed, and I'll make that set to something like 5, let's say. So 5.0. And then we'll come down here and we'll say lane change speed multiplied by delta. That way it happens over time. And now if we hit play, you'll see it's a lot smoother and a lot nicer. It feels better for the user. And that's just a really nice way to approach having this feel good, if that makes sense. Now, in order for our stuff to be able to move, we need to actually make the obstacles, and we need to actually spawn those obstacles. So first things first, we need to make that obstacle. So in order to make an obstacle, we'll come down here by our environment and we'll right click add in a child node, and we're going to add in a node 3D, and we're going to call this obstacle container. Like that. And we'll right click add a child node, and we're going to go and make an obstacle. So an obstacle can basically be whatever you want. In our case, we're just going to have 3 different types of obstacles. We'll have a high obstacle that you have to jump over, a low, or I guess a high obstacle that you have to crouch under, a low obstacle where you have to jump over it, and then a regular obstacle, which is just like a standard obstacle that you have to just dodge. So in order to make a standard obstacle, let's start by add in a static body 3D. Now I'm just going to call this standard obstacle, like that. And we're going to right click add a child node. We'll add in a collision shape 3D because it's going to need collision of some description. And I'm just going to make that into a box shape. Now I'm also going to right click and add in a mesh instance 3D, and I will go ahead and make it a new box mesh like that. Now I'm going to click on 3D, and you'll see that it is right here in this little section here. I'll grab the standard obstacle. I'm going to pull up the collision shape and the mesh instance, and we're going to scale this so that it matches our player. So I'll scale this guy up just like that. And we're going to grab our collision shape and we'll pull that up to the top as well. Now, when I grab my mesh instance, I'm going to make it a red color. And the reason why is because red is danger, red is scary. So that will help with showing the user that they don't want to actually hit this. So we'll add in a standard material. We'll click on this guy, go into albedo and change it to a red color. So we'll do that just like that. And there we go. So now we have some very basic obstacle. Now I'm going to need to make it so that this obstacle can move. So I'm going to right click, add in a script, and I will call it obstacle. .gd. And the reason why I'm doing an obstacle.gd instead of something else is because an obstacle.gd can be anything, right? I want this to be more like a base class for my obstacles, not a specific class for this one type of obstacle, if that makes sense. And what I'll do is I'll type enum obstacle type, and I'll basically have a couple of types. We had a conversation about this before, but there's going to be 3 types, right? Standard, low, high. And then I will go ahead and export var current obstacle type. Actually, I think it would be good to do current obstacle type, and we'll make that of type obstacle type, and we'll make that default to a obstacle type dot standard. And that's basically going to, like I said, be easy for us to read. So you can see here when you click, you can just pick which type it is. So if you have different types of obstacles, you have like a standard, a low, a high, and then let's say you have one that explodes or a rail or something else. That's what this is for. It makes it really easy to use and it makes it simple for us to kind of adjust. Now, since the obstacles are going to be moving, we're going to need to have some kind of speed value. So I'm just going to grab export var because I'm going to have quite a few exported variables here. So we'll do that speed, and we're going to make that a float. We're going to make that equal to 10, like that. And then we'll do the same thing. And then we'll probably need to add some other values. So for instance, if we have a boost or something like that, we're going to need to make the obstacles move faster, right? So that's kind of going to be important to keep track of. Now, first things first, we need to make it so the object comes towards us, right? And in order to do that, we need a process function. So we'll say func underscore process like that. And we'll say position.z minus equals speed multiplied by delta. And that's going to make the obstacle come towards me. Now, we might have to plus or we might have to minus. It just kind of depends. So we'll take a look. So I'm going to drag this guy out and then we'll hit play and see what happens. So it's going away from us. So we're going to need to make it go plus, right? We want it to come towards us. So therefore, we'll come in here. We'll go into our obstacle and we'll say plus speed. And that's going to force the obstacle comes towards us. Like that. You'll see it came towards us until it pushed us off the edge, which if that's the feature that you guys want, there you go. You guys have it. Your game's basically done, right? But what we're looking for is the ability for this obstacle to fly towards us and get spawned by our game manager. So what that means is that we need to create this as a packed scene, and then register it with our game manager and have our game manager do the spawning. And B, we're going to need to make it so that it will spawn into different lanes based off of however algorithm we want it to be. And B, we'll want it to spawn in a specific lane based off of some kind of random algorithm. So in order to do that, first we need to make this into a packed scene. So if we go back to our 3D scene, we set our transform to 0. This is a common problem that a lot of people make, is that they don't set this to 0, and that can cause a lot of problems. So we'll do that first. We'll make this into a packed scene. So it's down here now. And then we'll come into our game manager here. We'll right click, attach a script, and we'll call it game manager.gd. Now our game manager is basically going to handle a lot of stuff. First things first, it's going to handle our score. So we'll say var score, and we'll make that an integer, and we'll make that equal to 0. Because remember, we're going to have a score. The longer you run, the more points you get. And now we need to get a hold of our obstacles, right? Because we have our lower obstacle, our upper obstacle, and our standard obstacle. So instead of just referencing one of them, we should reference all of them. Now, in our case, we only have one for right now, but we will have more of them. So we'll hit @export var obstacle scene, and we're going to make that into an array, bracket, packed scene. And we're going to make that equal to an array like that. And you'll see now I have an array of objects. So I can open it up. I can drag in my standard obstacle. And in theory, it should work like that. And that will allow me to pull these objects from one central location. And it'll be really easy and flexible to add stuff later. So this is an actually really useful feature that was added, I think, in Godot 4.2 or something like that. It was relatively recent, but this was a huge change when they made this change. And now we're going to need to keep track of when we're going to spawn our stuff. So I'm going to say @export var min spawn time. I'll make that into a float, and we'll make that equal to something like 1.0. And I'm going to duplicate this and say max spawn time, because you want a min and a max. A max will basically say this is how long the game will maximally wait to spawn something. And the other one, the min spawn time, is how long what's the shortest time that it can wait. So that way we have a lot of flexibility on how much we do our spawning. And this will give you guys the best chance to build something super flexible for the future, so that way you can kind of dial it into what you guys want. Now we also need some kind of distance value for our spawn distance. So I'm going to say at export var spawn distance, and I'll make that also into a float, and I'm going to make that into something really wild, something like 50 meters. So it's really far out when it spawns, and it'll come towards you. And now we're going to need to spawn our stuff. And in order to do that, what I'm going to do is use a Godot timer. A Godot timer is really useful for spawning because it's a standardized thing that Godot has that always works. So I'm going to right click, add in a child node. I'm going to add in a timer, and I'll duplicate that timer. I'm going to need that second timer for later, but I'm just doing it preemptively because it's just a little bit easier to deal with right now than it is to do it later. I'm going to rename this as spawn timer, and I'm going to name this one as score timer. And the reason why I'm doing both of them, like I said, at once is just to save a little bit of time later. And I'll come in here and I'll click on spawn timer. Over here on the right, we can determine how long we want it to wait. In this case, I'll just have wait time as 1. And I'll click on node, I'll double click on timeout and select my game manager. I'll do the same thing here on my game manager. So now I have two functions that basically handle my timeout. One for score and one for spawning. So if we come into our spawn timer, we can come in here and spawn our blocks. So inside of our spawn timeout here, we can come in here and basically get our spawning work. Now, typically we would handle multiple spawned objects, right? Because we're going to have coins and boosts and things like that. But for right now, let's just spawn our one object. So I'm going to do some preventive coding here beforehand, so that way I can I can show you guys how to do like a randomized spawn here. So we'll say var obstacle scene is equal to obstacle scene bracket bracket, and I'm going to actually randomize, and I'm going to do a rand I to do a random int modulus obstacle scene dot size, like that. Now this probably isn't going to work because this is the same thing, so we could go self dot obstacle scene, and that should just work right there. Now once we have that, we'll have back our obstacle scene that we're going to instance. So var obstacle is equal to obstacle scene dot instantiate, like that. Now we'll go and spawn our obstacle. So now we need to basically position where our obstacle is going to be. So what we'll do is we're going to spawn it into a random lane. So first we need to select a lane. So we'll say var open lane is equal to rand I, like that, modulus 3. And that's going to basically just give us a 1, 2, or 3. And we can basically use this to determine which lane we want to spawn in, or we can do the opposite. So it's up to you guys on which one you want to do. If you want 2 obstacles to spawn in the empty lanes, or if you want it to spawn in there, that's up to you guys. What I'm going to do is say for I in range bracket bracket 3 colon if I does not equal open lane, like that. Then we'll say obstacle dot position is equal to a vector 3, and we'll need to determine where our lane positions are going to be. So currently we don't have a way to know exactly where our lanes are going to be. So I'm going to create an array up here of where our lane positions are. So var lane positions is equal to an array of floats. And I'm going to say minus 2.0, comma, something like 0.0, comma, 2.0. And of course, if you have more lanes than what I have, you can just add on to this and it will work. And then all we have to do is come in here, lane positions, bracket, bracket, I, comma, 0, comma, and then we get to choose our spawn distance that we did before. Now, if you want to just spawn the one in the proper lane, so if you wanted to grab the different lane that we had, you could actually pass in just open lane here into this and get rid of this 4 right here, and it would do that. But in my case, I'm going to make it so it spawns both, so you have to go in between the two obstacles. And now we need to add it to our obstacle container, because you remember, this is where our obstacles are located. So I'll just go $ obstacle container dot add child, and I will pass in our obstacle like that. And in theory, that should solve our problem. So I'm going to go ahead and get rid of that. And it should just work. If we turn this on as an auto start and we hit play, in theory, well, it crashed, so that's not a good sign, but that's a good sign. Invalid access to property obstacle seen in base node 3D. So this guy, oh, I see. So I did app capital O for this. So we need to copy that, paste and paste. We can get rid of this self. I made a mistake on that, so we'll go ahead and do that real quick. There we go. Let's reset. And nothing's happening, but we are getting errors, so that's a good sign. So cannot add child to obstacle. It already has a parent. Cannot add child static body to obstacle container. Already has parent obstacle container. Let's take a look at our remote and take a look at our obstacle container. So it looks like it has it as a child. And that would make sense because we're spawning one of them instead of two of them. So I think what I'll do is I will Control X, drop this in here, and then reset it and see if maybe that will fix our problem. So let's go ahead and refresh this. And that looks like that solved our problem, but our object is gone. So let's change our spawn distance from 50 to something like 10. And let's see if that gives us a better view of what we're looking for. And it might have to be minus 10. So just keep that in mind. And it probably has to be minus 10. So let's do minus 20. Let's try that as a number and see what that does. And there we go. You can see now it's spawning. Awesome. Very cool. So now we have an actual game going. Now, it is interesting because random I is never spawning on 3 or very rarely spawning on 3. So I wonder if Godot's random is actually random, and you'll notice that we can still go just over here and we don't have to worry about it. So that's something else we're going to have to look at. We can actually go off of our world and go as far as we want. So first things first, let's take a look at our player code here, and let's make it so that we can't go any further than the left and right that we expect. So let's go to our player code, and let me fix that real quick because that is going to be a big problem. So what I'll do is I'll come in here and I'll basically determine if our lane is the farthest lane, if that makes sense. So if target lane is greater than lane dot right, then you can do this, and then we'll do the same thing, but do this direction, and we'll do left. So that way you can never ever go off of the 3 lanes. So hopefully that will work. It did not. We can't really do anything. That's not great. So let's take a look. I might need to do this. Let's try that. Actually, I think, hold on. I think this needs to be left and this needs to be right. Nope, still broken. So let's see what happens if we flip this. refresh. There we go. And now you can't go past those things. You can't quite see it, but I'm hammering left and right, and it's not letting me go past those objects, if that makes sense. So now we need to come up with a way to handle jumping, right? So we want obstacles that the character has to jump over. So let's go ahead and do that. So in order to do a full-sized bar across the screen, we can't use the exact same code that we did for our game manager here, where we did this section here. We kind of need to handle it differently. So first, let's make the obstacle that the user needs to jump over. So I'm going to duplicate this standard obstacle. So I'm going to grab this guy and duplicate it, and I'm going to call it lower obstacle, like that. And I'm going to grab my lower obstacle. I'll go in here and I'm going to change this from this guy here to something a lot smaller. So smaller and wider. Now I need to make this a proper size specifically for the lower obstacle. So that means that the mesh instance needs to be a specific width because it needs to go across all 3 lanes. And since all of our lanes are mathematically 2 meters, that means that we can go with 6 and it should work. And then our Y, I'll just make it 0.5. That way it's nice and small. And Z can be 1. And then we'll just drag this guy down to the ground like that. So that way the user knows that there's something that they have to jump over. And then we'll grab our collision shape. I'm going to drag this guy down. Something about here, drag this over. And then drag this guy over. There we go. All right. And since this is a lower obstacle, I'll just type lower obstacle. I'm going to open this guy up and you'll see that we have a different obstacle types, right? So I actually don't need to make any changes here. All I have to do is change this to low, and there you go. And now I can go in here, go into my game manager, add lower obstacle to my array packed scene, and simple enough, right? Well, not quite. It will spawn, but it's going to duplicate it like crazy because right now we're just duplicating it and then we're assigning which one we're going to spawn and then we're duplicating it 3 times. But we don't want to do that because we don't know. We don't want our lower obstacle to be 3 objects. We could just get away with 1. Now, technically, if you wanted to, you could make this check if it's a lower obstacle, and if so, then spawn all 3, and that technically would work. Or we can just come in here and check for that in our code. So it's kind of dealer's choice on how you want to approach it. But in my case, I'm going to actually spawn it like a standard obstacle and make it go all the way across the bottom. So what I'll do is I'll come into my obstacle. I'm going to come in and say class_name obstacle. And that way I can cast this guy as a type obstacle like that. And now in order to kind of handle our obstacle stuff, we need to actually determine what the object is that's going to be spawned. So we can do this in a lot of ways, and it's up to you on how you want to handle it. You could create a array here that handles the different values, or you could spawn back this and then keep track of what the type is based off of like a second array or a dictionary. That could possibly work. But what I think I'm going to do is I'm going to instance the object. I'm going to say current OB is equal to obstacle scene.instance, like that. And then I'm going to check to see if current OB dot, and they have a type, right here, current obstacle type. So if the current obstacle type is equal to, and we probably want to get some auto completion here. So let's come in here and say class name obstacle like that. And I'll come in here and just say obstacle dot obstacle type dot low, then we will go ahead and do our low stuff. Else we'll do the rest of this stuff here like that. Now, when we do our obstacle stuff, you'll see that it's kind of mad at me because it doesn't have an indented block. Don't worry about that. We will get to that. When we want to instance our obstacle, we can basically just come in here and say var obstacle is equal to obstacle scene, instantiate, and basically grab this code, paste it here, and then tab it out so that it matches what we need. So we'll bring this up, tab it in like that. And instead of lane position, I will just say 1, and that should handle it. Now, we still have an issue because of our current obstacle just existing. So we'll say current obstacle dot queue free. Again, this is not the most ideal way to handle it, but it will handle it. The other way that we could handle this is by using a dictionary and then keeping track of the key value pairs and basically having an index that is associated with that key value pair. I don't know if I like that better or if I like that worse. I think both of them are not great options, but this one at least works for the most part. So now if we hit play, you should see when it spawns a line, it spawns right in the middle and our character just runs right over it. But at least it's kind of doing what we want. Doesn't look like it's big enough or it's centered. Let me see. Yeah, it doesn't look like it's centered. So we're going to have to take a look at that, but it at least is working. Now we're going to go to our lower obstacle. Let's take a look at the object here. It looks like it's in the center of the object. So my guess is it has something to do with the actual spawning code. I'm going to pull this guy up quite a bit because we want it to be quite a bit taller. And I'll make this just a bit thick, something like, there we go. And if I take a look at my lower obstacle, that should work just fine. And now I'll come into here, come into main, and let's see what's going on. So 1 means that it's probably spawning not in the center. So if we come to here, let's see. Well, that would make sense because it's 0 is the center, not 1. So we'll set this to 0 and save. Now we'll hit play and let's see what happens. And there we go. Now you can see our character just kind of hops over it. Don't worry, but if you really want it to be an obstacle that requires them to jump over it like this, you could just adjust the height so that it barely clears it. So you could come in here and adjust this to be quite a bit higher. I think the player jumps almost 2 meters. So you could come in here and basically pull this up to something like this, and then basically expand this quite a far up. So, and then that should solve that issue if that's what you guys want to do. You'll see here. There you go. So now it's holding the player back and it knocks him off. So perfect. That's exactly what we wanted. Now, in order to actually do an above obstacle, we need to make it so that our character can kind of slide underneath other objects and things like that. Now, I'm going to make this really simple. And what I'll do is I'm going to basically come in here into my player, and this collision shape, while it's perfectly fine for what we need it to be for right now, what we'll do is we'll duplicate that collision shape. We're going to bring this kind of down here. We're going to make it much smaller. So I'll bring this guy down and pull it down. And that's going to allow our collision shape to be a lot smaller for our character. And that's going to allow us to basically switch between these collision shapes and disable and enable them as we need. That way, we can actually crouch under objects without causing any issues. So what we can do is go into our script here, and we can basically edit our script to make it work for what we need. So first things first, in order to crouch, you need to be able to press down. So I'll come on here and say if input dot is action just pressed UI underscore down like that, colon, and then basically we'll handle it from here. And actually we should also do and is on floor. Like that. That way we make sure that we're on floor, because if we're not on the floor, we can't crouch. We don't want the user to be able to jump and then basically crouch immediately, right, while they're in the air, because that's going to reduce their size and they could hit something. So we want to make sure that we make it so that they don't have that option, right? If you remember how Halo does crouch jumping, right, that's because they don't check is on floor when they do their crouch. So that's kind of the reason why that exists. But in our case, we don't really want that. So we're going to do that. And then if we are, and we have our button pressed, what we can do is hit $, collision shape 3D dot disable. Now, what I'll do is change this from collision shape 3D to standing collision, and then we'll change this one to crouched collision, like that. And I'll just change this to $ standing collision dot disabled is true. I'm not going to worry about disabling my crouched collision. It doesn't matter. It should be fine. And once we have this disabled, that means that we'll be able to crouch underneath objects. And basically, we should be relatively good with just that, for right now at least. And now that's going to disable our actual collision here, right? So that should allow us to slide under objects. So if we go in here and we build our upper obstacle, so I'll just open up my lower obstacle here. So we have our lower obstacle. I'm going to control duplicate that. So I'm going to grab this guy and duplicate it like that and do upper obstacle. Like that. And basically, we'll rename this as upper obstacle. And then we'll make this a high obstacle. And then we'll just drag this guy up something about here-ish. If I remember correctly, the player is about 1 meter tall or 2 meters tall. So if we take a look at our main scene, take a look at our player, click on our X, you'll see that our player is 2 meters tall. So if we set it to 1, that should be fine. And if we adjust our collision shape to make sure that our crouched collision is only 1 meter tall, so we'll set this to something like 1, like that, that should allow us to slide underneath it. Now I'm going to double check our lower obstacle, make sure it's just slightly above 1 meter, so that way we can guarantee that we're not going to hit it, because we might still hit it if we're not careful. Now, and actually, now that I'm looking at this, let's set this to 0. So that's my fault. So we'll change this to 0. And then we'll set these two guys up 1 meter in height. And we're going to have to adjust our collision shape to match. So we'll bring this guy up just a tiny bit. There we go. And that should allow that to not hit the user and fix that little issue right there, because we had a little triangle that said that there was a issue with the object itself. So we'll do that. And then you'll see if we hit play, and then if we go into our game manager, we add an element, and then we drag our upper collision onto here, it should randomly spawn a collision object. So we'll hit save. And if we double check our code, I want to make sure that it's right before I start saying it's going to be okay. So right here is where it instantiates a obstacle low. And you can see that it's going to do that. This does 3. So we're going to need to say if current object and or current ob dot current obstacle type. Actually, I could probably just grab this guy right here, copy, and then basically just paste this in. So we'll just do that, paste. Current obstacle type is equal to obstacle dot I, like that. And that should allow us to spawn those guys in just fine. So now we should be able to hit play. You see we have a low and then we have a high. And we can't crouch it. And also, we're not colliding with it, which is interesting. So let's see why that's the case. So I'm waiting for another one to spawn. Yep, so we're not colliding with it at all. But interestingly enough, we are colliding with these. So my guess is that our object is not getting remade. So let's take a look at our code here. You can see we're setting this to disabled is equal to true, and then we are doing nothing after that point. So we need to basically reset it after some time. So let's come in here and let's do that. So we'll say at export var crouch duration, and we're going to make that equal to, we'll say 0.5 F. We're going to do a 0.5 seconds, which I forgot F is for C sharp. And then we'll say var current crouch duration, and we're going to make that equal to, and basically we'll make that under our ready, which we don't have a ready here. So we'll say func ready like that. And we'll just come in here and say current crouch duration is equal to crouch duration. And that will allow us to basically allow us to set this value, and then on startup, it'll choose that value. So we can adjust how much crouching we're going to do and how long we're going to do it based off of that one parameter. So now we can also add in a Boolean called, and now we can basically come in here and set our state here to our crouch, if that makes sense. So we'll need to add in a value of what our current state is. So var current state, and we are going to make that of type state like that. And then we'll default that to state dot running, because by default we're going to be running. And now we can come in here and just say state current state is equal to state dot sliding. I guess technically it's not crouched, it's sliding. So we really should change this to sliding duration and then current sliding duration. And then change these guys over. So that way they just kind of match up with what our code looks like. That way things aren't confusing for the user or for us later in our code. So once we have this, then we can just say current sliding duration is equal to sliding duration. And then we'll say if current state is equal to sliding, state.sliding, then we can go current sliding duration minus equals delta, like that. And then we can check if our, we'll do double equals here, if our current sliding duration is less than or equal to 0, then we can set our state equal to state.running. And then that will allow us to basically change us back to our running state. And you might be wondering why we would do this, right? And the reason why is because let's say we want different speeds, right? So when you're sliding, you run at a different pace, or if you're sliding, you can't pick up coins, or if you're jumping, you can't pick up coins, right? This gives us that flexibility for us to be able to change all of that. And I'll show you guys other ways to handle this in a bit later, but right now, I'm just going to do it this way. So now we can say current state is equal to state.running, and then we can go from there, and that should work. And also we can come up here and say, if we are on floor and our current state does not equal state.sliding. And basically the reason why is because then people can't hammer on the down arrow and constantly slide forever, right? And their sliding duration doesn't reset. They have to wait until it gets fully done, your slide is complete, and then it will reset. That way the user can't gain the benefits of being sliding forever, if that makes sense. And now we also need to come in here and make one small change where we do $, standing collision dot disabled is equal to false. And that will allow us to have our standing collision once again. And now we can hit refresh, and let's try that now. So we got a guy, we're going to crouch, jump, we can get hit, and we're done. Perfect. So we definitely might have a slight small problem. Let me see. Jump. I cannot jump, which is interesting. So let me try taking a look at this again. So jump, slide, jump, jump. Okay, that was interesting. So our player is having some wrinkles here. So our current state is running. It might be that 0.5 seconds is way too long. So let's try like 0.2. Maybe that would be a more reactive feel. So let's see if that works. So jump, jump, slide, over, slide, slide. So you can see that we're just uncrouching almost immediately. So we need a little bit more time, but I think that that's probably better off because now we can go slide, bam, but I can't slide for that for some reason. So when I get hit, so that's interesting. 0.2 seems to work, but when we get hit, it might be that our lower obstacle might just be a little bit too high up. Yeah, I'm guessing that it's slightly clipping. Let's try bringing this up just a touch bit more, so that way we can guarantee that we're not hitting it. And I'm going to double check my collision. That should work. As you can see that this is slightly off, so I'll pull that up just a touch. And then let's see if that works, because it, like I said, it's going to be a little bit finicky until we get it right. So we just need to get it right. So interesting. I'm not able to jump. I wonder if, so when I get pushed, I can't seem to jump. It seems like my interactions are broken. Can I go left and right when I get pushed? Yes. So I'm curious if when we do our jump, if we do current state is equal to state dot jumping, and then we can come in here and say if is not on floor and current state not equal jumping, like that, because what I think is going on is that we're getting pushed down slightly by our jump vector, and because we're getting, or by getting pushed back, we're getting pushed down slightly, and I think that's what's causing the issue. So if I do that, what does this do? So this is definitely not going to, this is going to give us gravityless, right? So, we'll take a look. So no, that's not the case. So it's not the gravity that's causing the issue, because we set our state here when we press jump. So in theory, when we hit jump, we should have 0 gravity. So it's not the gravity that's the problem, because I thought maybe it would be this. But I wonder what would happen if we do this. Let's see what happens if we click on player and we change the jump velocity to something crazy like 10. Does that make a difference? And it probably will, but let's see what happens. So we'll crouch, we'll get hit, jump, and yes. So, or maybe not. It could be that we're not on the floor because we're getting pushed back, so it's not allowing this to fire off. So let me see something. So what if we get rid of this section here and we take a look at it? So probably same thing with this. It's probably also going to be a reasoning, but we'll take a look. So we'll come over here, we'll jump, we'll get hit, jump, and yeah, that seems to be why it's broken. So you can see that it's not allowing us to do stuff because when we get pushed, yeah, that seems to work. So it looks like when we are getting pushed back, we're getting shoved up above the floor, and that's forcing us to not get collision, if that makes sense. So what's going on is basically when we hit the floor here, we are saying, yes, we're on the floor. But when we get hit, we get knocked backwards. When we get knocked backwards, it bounces us up off the floor just slightly. So it kind of traps us and we can't really do anything about it. So what we need to do is we need to change this to be a bit better. So I'm going to go in here. I'm going to right click, add any child node. I'm going to add in a raycast 3D. I'm going to go into 3D view and I'm going to pull that raycast up just a tiny bit, something like this. And I'm going to tell it to point down. So you'll see that it is pointing down like this. And I'm just going to give it something like 0.3 or so. So it's slightly intersected. That way, if we get pushed up just slightly, we're still technically on the ground. And that should give us just enough space that we should be okay. And now we can come in here and basically just raycast the floor and see if we are touching the floor. So we'll come in here and we'll just say, and so we can basically come into our jump code like so, and $raycast3d.is colliding. And then we'll come in here, we'll do the same duplicate, but we'll do it for our sliding as well. And raycast3d is colliding. And that should allow us to basically keep track of if our player is on the ground without using is on floor. So if we do that, you can see when I hit jump, it only lets me jump a little bit. But if I get hit by this guy, I can jump over it. And that allows us to have a little bit more dynamic of a game. And it makes it feel a little bit more responsive because we're able to crouch and jump over these things and get pushed back. And then of course, you know, if we get stuck, we can actually get out of being stuck, which is good. That's what we want. Awesome. So now we basically have a very basic game. But as with all games, we need to have the ability to crouch under obstacles. And also you'll notice that our obstacles are spawning really close to us. So we need to fix that too, because that's not great. But it is working out quite well. So now let's take a look at how we can add a score, and let's make it so it spawns a little bit further back. So here's our spawn distance, -20. So let's do something like -50 and see if that helps. So if I hit play, yeah, that's a lot farther back. We could probably even go farther, actually. We could probably change this to -100 and see how that goes. So that's better, I think. But I still think 100 is probably too low. I would like to see it much further back. So maybe we could go with something like -500, and maybe that gives us a better spawn distance. Let's see. Okay, maybe that might be too far. So let's do something like 200. And I know I'm fiddling with this, but I want it to be good for you guys. 200 is still way too far, so let's go with like 150. Man, that is still way too far. I feel like it didn't save when I did 100 that one time. All right, so 60. Go with -40 maybe? Still feel like that's a heck of a distance. -20 is basically back where we were. But they still are spawning way too far out. So I'm not sure. I wonder if the spawn distance has something broken with it. If we take a look, and I know that this is probably not the most exciting thing in the world, but let's take a look at it real quick. So when we spawn our stuff, we go here, obstacle position, 00 spawn distance. So that's legitimately fine. Add child obstacle, current queue, yep. So that should be fine. It might just be the camera angle that makes it look a little weird. What if we do 30? Yeah, I think it's just the camera angle that makes it strange, or something's not getting updated properly. So I'll just stick with -30 for now because I'd like to roll the tutorial forward. So what we'll do is we'll keep that, and then we're going to come in here and say on. And so since we'll keep it like that, let's talk about how to do score, because you can't have a game without having a score, right? So in order to do a score, we already have our score timeout. You can see our timer here. Every second, you're going to get a score. So simple enough, right? Well, and in order to have a score, you need to have some kind of thing to store that score, which I do. It's called score. It's right here. So we'll come up here and type score plus equals 1. Simple enough. So now every single second, you're going to get 1 point of score, which is perfect. But now we need a way to display that score for the user. So let's come in here. Let's right click, add in a child node. Let's add in a control node like so. And let's just call this UI manager. I do like my managers. So MANAG like that manager. We'll right click. We will attach a script and we'll call it UI manager.gd. Now what I'm going to do is I'm going to pass the score to the user interface to be displayed. Now, there are 2 ways that you can approach this. The first one is by going in and basically dynamic referencing the object from the game manager and then telling it to update it, right? Or we can tell the UI manager to listen to events to receive that data. And it's up to you on which one you guys want to do, but I'm going to go with the signal method. And the reason why is because this serves as a good starting point for you to learn how signals operate. So let's right click this guy, add in a child node, and let's add in a rich text label. Let's go into 2D. And let's put this in the upper right-hand corner, nice and simple. So we'll just drag this up here and type score, : simple enough. And then let's put that under our UI manager. Let's make our UI manager full screen. So we'll come in here and make it full rect. So it's the full size of your screen. And then we'll just anchor this guy in the upper right-hand corner. Simple enough. Now, what we'll do is we'll have a function called update score like that. We'll pass in a score like that. And then we'll say $rich text label dot text is equal to quote score : and then we'll pass in our score. So it'll be plus str score like that. Now we could go into our game manager and then just say $UI manager dot update score, like however we have it, or we can do this in a little bit more fancy way. So if we come up here and we type signal like that, we can create what's called a signal. And a signal is basically like an event. We can say, hey, an event happened, something happened, right? And we can come in here and say, score updated, and we can pass in a score and we'll make that a type int. That way we know exactly what it's going to be. And now we can emit that signal whenever we get score. So we'll come down here and we'll type score updated dot emit, and we'll pass in our score. Simple enough. And then we can click on our game manager and go to node and then score updated. We can double click on that guy, go into our UI manager and hit connect. And all this is going to do is it's just going to update our score. Now, I really don't need that function, so we can just come in here and do that. And then there we go. And now anytime our score gets updated, our game knows about it. It says, hey, our score got updated, and then it broadcasts it out to this node and we're good to go. So you can see if I hit play, you can see we have a score. And in theory, it should update, which it doesn't look like it is. So that's not a great start to what we were trying to do. So let's see why. So if I put a breakpoint here, does it actually fire off? It doesn't look like it's going to, so that's not great. Let's see what happens. Is this getting fired off? My guess is no. So this isn't getting fired off. So that means that odds are likely our score timer is not turned on, which it's not. You can see right here, auto start was off. So therefore, this wasn't getting updated. So that's why it was broken. So now if we hit play, in theory, you should see our score ticking up. 1, 2, 3, 4, 5, 6, 7, 8. So perfect. Now we have a score. Awesome. So now our endless runner is actually a game, right? It actually does something for us. We actually have a score and we have the ability to play our game. So now the next big question is, what if I want to add other things like coins or boosts or things like that? So let's talk about that. So if we want to spawn coins, all we need to do is come into our game manager here and actually create a way to spawn that stuff. So first things first, I'm going to come in here and say, instead of obstacle scene, I'm going to come in here, duplicate this guy and change this to power ups scene like that. And that'll add in another array here so we have something to spawn with. Now we need to actually create our power up. So I'm going to go in, create a new scene. I'm going to make that into a 3D scene, of course, and we'll right click add a child node. I'm going to add in a mesh instance like that, and I'll bring it in as a CSG mesh. I'm going to make it a new box mesh, and I will make it much smaller than what it actually is. So we'll just kind of scale it down to be nice and tiny. We'll drag it up to be somewhere in this area here, and we'll come in here, change the material here to a new standard ORM, and we'll change it to something like a yellow color. That way it actually looks like it should a coin, and we'll kind of make it about, I don't know, about yay big here. And it should look pretty yellow. So let me select off of it. And you can see it's nice and yellow. And then I'm going to right click, change the type and make this an area 3D. I'm going to right click, add in a collision shape 3D, and I will make it a box shape. Now, when I bring this up here, it's going to go like that. I'm going to resize this to actually match. So we'll do that real quick. So drag this guy up, drag this guy over, and then drag this guy over as well. And then we'll need to drag this guy over and this guy over as well. So that way we can actually collide with this coin. And I will type coin like that. And there we go. Now, because this is an area 3D, we're going to have a way for us to be able to handle that collision, because the user is going to collide with it, right? And they'll be able to pull the event from there. So I'm going to hit Control S. I'm going to save this as a coin, and I will go into our main scene, and I will drag our coin right up into our power up scene. Now, when we collide with that coin, it is an area 2D. Or area 3D. So since it is an area 3D, we're not going to catch that collision, right? So we need to create an area to do that. So I'm going to come in here and type area 3D, and I will right click, add in a collision shape, and I will make it a capsule shape and drag it up to fit the player. And now I can come in here and say, whenever this area 3D collides with it, so we'll call it power up collider like that. I can come in here, go into node and go on area entered and hook that up to my player like so. So now I have a on power up collider area entered. So now I can guarantee that that coin that hits me is going to fire off right here, if that makes sense. Now, once we have the power up collider area entered, we can come in here and basically make it so that when we collide with this object, we can emit that we're adding extra score. So how we'll handle this is much like how we handled our game manager when we received more score. We'll come up here and we'll create a signal, and we'll say add score, and we'll pass in a score, and we'll make that an integer like that. And then we'll come down here and we'll basically just say add score, and then we'll pass in dot emit, and then we'll pass in whatever we want to do for our score. Now, if you guys want to, you guys could always, and here we can put the value that we want to emit. Now, we could make this into a random value, or if we wanted to just add 10 points, we could do that. Or if you guys want to, you could come into our coin and then add a script to it, and then we can script that value. So let's go ahead and actually script that value. So if we take a look at our obstacles here, you can see that we have different obstacle types and things like that. So we should do the same thing, but instead for pickups. So we'll right click, attach a script, and then we'll call it pickup. class.gd, class underscore name pickup. And then we'll come in here and say enum pickup type, and then we'll pass in our types. So in our case, we'll go ahead and just say coin, comma, maybe a power up, right? Things like that. So we can have whatever we would like inside of here, or perhaps like a boost or something to that effect. Now, with this, we can actually come in here and go at export var score like that, and we'll make that equal to 1 by default. So now when we click on our coin, we can actually determine what our score is going to be. And now we can come into our player here, and instead of just omitting add score, we can come in here and say if area is a pickup, then we can add our score, and we can say area dot score like that. And that will allow us to omit the amount of score that object gives us. And then that allows us to have a nice, simple way to add score. So we could do something like 10 or even 100 if you guys would like. And now I can come into our player, and we can actually grab that signal add score and attach it to our main game manager as well. And then we can take this add score, double click on it, and then come in here and attach it to our game manager like that. And then we can basically just do on player add score, right? So we can type score self.score plus equals score, and then emit that update. So score updated.emit like that. We'll pass in our self dot score like that. And that will allow us to actually have a updated score for our users so that we can actually pick up objects and get more score out of it. And now we need to be able to spawn those objects. So if we take a look at our game manager here, let's actually come up with a good way to actually spawn this stuff. Now, when we want to spawn our coins, how do we actually want to approach it, right? We can spawn coins at random, right? We can go in and say on spawn timer timeout. Let's spawn another random object and then go from there. We could attach it to our spawnable objects, right? There are all sorts of different methods. But we don't ever want the case where a coin is overlapping from an obstacle. That means that these guys need to be wrapped in an if statement so that they are separated, right? So that way it never spawns those two guys at the same time. So in order to do that, let's come up with a random value to handle that. So we'll say var rand value is equal to randf like that. And that will create a random number. And then we'll say if rand value is less than, and we can come up with some kind of value. So random float is really useful for creating randomness, right? And it's going to give us a value from 0 to 1. So we need to come up with a coin spawn chance, or at least a pickupable spawn chance. So let's go up here and create a value for that. So at export var pickupable spawn chance, and we'll make that into a float like that. And we'll make that equal to something like 0.3. 0.3 means a third of the time you're going to get a coin or something like that. And so we'll say if it's less than pickupable spawn chance, then we will go ahead and spawn a pickupable. Now we can handle this in a lot of ways. So it's completely up to you on how you want to handle this, but we can come in here and just spawn our coins. So if we take a look at our inspector and we click on our game manager here, you can see that we have this array of pickupable objects, or power-ups as they're called in this specific tutorial. You can see we have a coin packed scene here. So we can basically grab this bit of code here, like so, and we'll pass in an else right here, like so, to make this guy here only spawn when it's not the pickupable object. And then we'll come in here and say we're going to instantiate that object. And then we basically need to pick an open lane and spawn in that object. And so what we'll do is say var spawned lane is equal to rand I modulus 3, like we did before. And then we can basically take that spawned object, that instantiated object, and move it into that lane. So we'll say obstacle scene current obj dot position is equal to vector 3. And we need to pass in our lane position. So lane positions bracket I, comma, 0, 0. Now we might need to adjust this Y float to make it so that our coin spawns properly. If we take a look at our scene, since this is already above the ground, we should be good to go. So that's good. So we'll take a look at this. We'll say our current object in lane positions, and it's going to be the spawned lane instead of I. And then we can come in here, hit enter, and then do add child, and then add in a child object, and then I'll hit $ obstacle container dot add child, and then we'll add our obstacle like that. And that'll make it spawn. Now, if we take a look at our obstacles, you can see our obstacles have a function process delta. So we'll grab that and duplicate it for our coins because they need to also move towards us as well. And we're going to need to have a speed value. So export var speed, and we're going to make that default to the same thing that everybody else defaults to, which is 10.0. And if you wish to, you can do :float as well if you want to type it. But that's just making sure that everything kind of flows the same speed so that you're not confused and not messed up, right? And now we can hit play, and we should hopefully have coins spawning as well. Well, we have some objects spawning in a really weird way, and we have no coins spawning. So that's not good. So let's take a look what's going on here. So first things first. Oh, I see. I put obstacle scene instead of our coin. That's my fault. So we'll come in here and say power up scenes rand I, and then power up scene as well. And then you'll see here that we need to do spawn distance. So we'll change this to spawn distance as well. That's my fault. And that should work. If we refresh it, let's see what happens. There's a coin. We pick it up. There's 14. There's 25. So perfect. Those objects are a little small. So we're going to have to take a look as to why they're so small. But that's exactly what we wanted. Awesome. So now we need to make those objects bigger, and we also need to make them on collision disappear, right? So first things first, on area entered, double click on that. Let's connect it to ourselves, and we'll just queue free like that. Now we'll just get rid of it. And then also we'll take our CSG mesh and we'll make it a little bit bigger because it's quite small right now. So we'll make it 2 by 2 by 2. And then we'll do the same with our collision shape. So we'll make that, if I take a look at my collision shape, probably 2 by 2. That's way too big. So let me take a look at my transform. My guess is my scale off? It isn't. So that's a little strange. I guess the X, this is 2 by 2, unless I scaled this incorrectly in the transform here, which I did. So that's my fault. So we'll set that equal to 1. And that will make it into a full-sized object. We'll come in here, make this 1 by 1 by 1. Is that going to work? I think that's still way too large. So let's do something like 0.5 by 0.5 by 0.5. There we go. That's quite a bit smaller. That should work. And we'll do 0.5 by 0.5 by 0.5. And that will also make it just about the right size. So now if we click on main, you'll see that it should allow us to see the coins a bit easier, and there we go. And when we touch them, they disappear. Perfect. That's exactly what we wanted. Awesome. Very cool. So now that we have that going, So now that we have coins spawning, let's talk about how to spawn them in a row. Because typically when you're playing a game, they don't have the coins just piecemealing to you, right? They have them coming to you in a line and try to force you into specific direction. So in order to achieve this, let's first come into our script here and let's look at our spawner code. So we have a random spawn pickupable chance, right? And here's where it spawns our coins. So let's come in here and say if current obj dot, you can see I have current obstacle type, so we're going to treat it much like the same. So go to our pickup and do pickup type instead, and I believe it's actually not set here, so let's hit enter at export var current pickup type, and then we'll make that equal to pickup type.coin by default. So that way, typically we're just going to say it's a coin, but if it's not, then we can change it when we click on it in here. So you can see right here, I can make some adjustments here. And now we can come back in here and say if current obj dot current pickup type is equal to pickup, and I believe we called it pickup. That was it. I don't like the name pickupable, because that would make more sense. So we'll do pickupable instead, like that. Dot pickup type dot coin. Then we know that we can actually change how we're going to spawn our coins. So when you spawn a coin, right, we're going to want to basically random a number and then create a formation based off of that random number. So in this case, I'm going to create a function, and the function that I'm going to create is called spawn coin formation, like that. And these guys right here can be commented out for now, because later when we want to spawn something else like a boost object or something like that, we'll probably need this code for that. Now what we will need to do is after we run this spawn coin formation, we're going to need to queue free our current obj. So we'll dot queue free and just get rid of that. Now, if we come down here, we can create a function, func spawn coin formation. Now, when we spawn our coin formation, what we'll do is we'll come up with a formation type, kind of like how we did up here when we created a open lane. So we'll say var formation type is equal to rand I modulus 3. And I'm just going to do modulus 3 because I'm going to give you 3 different formations, and then we'll go from there. And then we're going to do what's called a match. And a match is basically a switch statement for those of you who know what those are. If you don't know what that is, then I'll explain it a tiny bit for you. So a match allows you to have values. So like 0, 1, and 2, right? Because we have a rand 3, right? So we can do up to 3 values here. And then we can basically have 3 different ways to handle our spawning of our objects. So first things first, it could be a single coin. So var coin is equal to, and we'll come up here and we'll say the obstacle scene is going to spawn a coin. So this is a rand I in the obstacle scene. And then we're checking, or I'm sorry, in the pickup spawn chance. So you'll see that this is spawning in that obstacle scene. What I'm going to do is just bring in my obstacle scene here, like that. And I'll come down here and change this to be coin scene, like that. So var coin is equal to coin scene dot instantiate. Now, if you want to, you can actually colon packed scene, and that will help with getting this, you knowing exactly what you can do with your coin scene. Then we'll come in here and say var lane, and we'll make that equal to rand I modulus 3 because we have 3 lanes. Arguably, if we wanted to make this scalable, we could adjust this value to be a value that's exported, but in our case, we're only going to do 3 lanes, so we'll just stick with that. Typically, there are 3 lanes anyway. Then we'll type coin dot position, is equal to vector 3 lane positions bracket bracket lane comma 0 comma spawn distance. Now, remember, that's exactly how we did our coin spawn before, right? So if you see right here, we did 0 spawn distance. So this is effectively just keeping this bit of code here. We really could just duplicate this and then paste it. And then that'll basically allow us to spawn those coins. And now we'll come in here and we'll say, how about if I want to do a line of coins, right? So var lane is equal to, arguably, I'm looking at this, we really could do something like this, actually. Let's take lane, pull it out, drop it here. That way we can just say our lane is set, right? So then we don't have to worry about that. And now what we could do is say for I in range, bracket, and the number of coins to spawn. So if you want a lot of coins or very little coins, that's up to you. You could just do rand I, bracket, modulus, something like 7, right? And then that's going to give us a random number between 0 and 7. So that should give us a way to spawn our coins and have it be a random number. And now I should be able to come in here and say var coin is equal to coin scene dot instantiate, like that. That's going to instantiate those coins. And then I'll say coin dot position is equal to vector 3, much like we've done before, and do lane positions, bracket, lane, comma, 0, comma, and then we're going to need to do spawn distance, right? Much like we did before. But all this is going to do is it's going to spawn the coins on top of each other, right? We need to offset that value by I plus multiplied by 2. And that'll just give them a nice, good line to spawn them in. And then I can add in my obstacles. So we'll say $ obstacle container dot add child, and then we'll add in our coin. And then the last one, we're basically going to do the exact same thing, but this time let's do it in a diagonal pattern, right? And a diagonal pattern means that we can only spawn it in a diagonal, right? So we can go left to right. So how can we do that? Well, that's really simple. So first things first, we will get our start lane, which we already have, and then we're going to do a direction. So var direction is equal to 1 if rand f bracket 0.05 is greater than 0.05 else -1. And all this is doing is it's just basically allowing us to take this object and say, hey, if we do a random float and it's less or greater than 0.5, then go ahead and set it to 1. If not, then do -1. That way we can start it from one side of the lane or the other. Also, this needs to be coin, not the other one. And then we can come in here and say, if lane index, if lane is less than 0, then lane plus equals 3. And that will basically just choose to spawn it in a proper bounds. We want to keep it within 0 to 2, because if we go outside of those values, it's going to break all of our code. So we'll do that and make sure that that gets handled. And now all we have to do is say for I in range 3 colon and say var index is equal to lane plus I multiplied by direction, like that, and then modulus 3. Now I know that this looks a little weird, right? So what we're doing here is we're basically pulling our current lane that we expect, our I value, from our I range here, and then the direction that we pulled back here. So basically which lane we want it to end up in. So then we're basically just determining which lane we're going to spawn in. So if it's 0, this will be 0. If it's 1, this will be 1. And then if it's 2, this will be lane 2, or I guess -1 in this case. I believe it's -1, 0, and 1. If it's 0, then this is going to wrap around, start spawning in center, then the right, and then the left. So that's kind of how this is approached. And then we need to spawn our coin. So we can basically just grab these guys, copy it, and paste. And then
For our spawn position, we basically need to do the exact same thing, but instead we need to change this from lane to index, and that should work. And in theory, this should solve all of our issues here. So let's see what happens if we hit play. It'll probably break, but we'll see. Could not find pickup in current scope, so that's not a good sign. But if area is pickup, that's because it's pickupable now. It's not pickup. So we'll refresh that. And then let's see what it does. So you can see now we have 3 coins in a row. We'll come over here. We have a single coin, another single coin, and then crouch. And you can see here is one where they are not in a straight line. You can see how you had the 3. That's the diagonal pattern that we're looking for. Now, I think the diagonal pattern code might be a touch wrong, but we'll have to take a look at it later. But there we go. Now we have some coins and things spawning as expected. Now, we probably should create some kind of animation to make this feel a little bit better. But overall, we got a game on our hands here. So now let's talk about dying, right? And creating the death state and about how to handle scores and scoreboards and things like that. So let's kill this real quick. And before we do that, actually, let's take a step back and let's talk about difficulty, because we need to increase the difficulty of the game over time. And that's something that you want the user to lose, right? You don't want them just to lose because of fatigue. You want them to lose because the game gets harder as time goes on. So in order to create a way for the game to get harder, we need to add in some kind of speed multiplier. So let's come up here and do var speed multiplier. We'll make that a float, and we're going to make that equal to 1.0 real quick. And basically what this is going to do is it's going to allow us to spawn objects in with a speed multiplier. And now we can come in to our obstacle spawn code, which is... oh, this is on our player. My fault. We'll get rid of that. We'll want to go into our game manager, and then we'll want to do a speed multiplier. And then we'll come down here, and when we do our objects, see we have a current object here. When we spawn in that object, we need to actually instantiate it and then set its speed value. So we'll come in here, we'll go obstacle dot, and if we take a look at our obstacles, we have speed with a capital S. So speed is equal to obstacle dot speed multiplied by speed multiplier. And then we basically can take this guy, copy it, come down here, paste, and then we take a look. There should be one more where we're instantiating stuff. We have our coin spawning, which we can adjust that really quick. But I'm looking for a... I think that's all of them. I think we're only spawning, yeah, here we're spawning 2 obstacle types, so that should work. And then we can come down here in our spawn coin. We can change this to coin, like that. And then we can grab this, copy it, paste, and then do it one more time right here. And that's going to allow us to control all of our speed based off of a speed multiplier. And now we can do all sorts of fun stuff. So for instance, whenever the score gets updated, we can come in here and increase the difficulty. So we can say speed multiplier plus equals, let's say, 0.2. I know that that's probably not the best way of doing it, but we can try that really quick and see what it does. And then if a user picks up a coin, I believe we have a on score timer timeout. We can also do 0.2. That way, as they pick up coins, we'll make that 0.4. Maybe it goes faster. That will allow us to speed up our game. So if we come in here, you'll see the objects are spawning in. Oh, I'm very bad at my own game. And then you can see that it gets harder as we play. And there we go. So now we also could make it so that, of course, we're going a bit too quick for what we need. We probably could do something like 0.02, I think, and 0.04 probably is a better choice. But that's how we can make our game more difficult for our users. And then also what we can do is we can make it so that the score gets multiplied with it. So we can come in here and say score plus equals 1 multiplied by speed multiplier. And I know that this is a float, so maybe we need to go 1 plus 1 multiplied by speed multiplier. That way we're always guaranteed a 1 score. And then we can do the exact same thing down here. When we do our score, paste, plus, and then we could basically say score multiplied by speed. So that way, as the game gets harder, you get more score, more or less. And that's how we can handle all of that. And that's how we can make a good, difficult game. Now the question is, okay, so I have scores, I have difficulty, I have things like that, right? Things get faster, things become more difficult as time goes on. How can I handle the death state of my player, right? How can I reset? How can I have a player that dies, right? And the simplest way to hold that or to do that is to right click, add in a child node, and add in a area 3D. And then let's right click that area 3D, add in a child node, and add in a collision shape. Like that. Now, Godot actually has a tool for handling when someone falls out of the world, and that is a world boundary shape. And a world boundary shape runs the entire size of the entirety of Godot, right? It goes for the entire world right here. And all we have to do is just drag this down below the player. So that way, when they get knocked off, they die. Very simple. And then when this area detects that somebody has entered it, we're going to tell the game manager that that area has been entered. And this is our death plane. Now, we could, of course, change this really quick to be death plane. Like that, and then we can kill this method here. So right click disconnect, right click connect, and let's connect that to our game manager here. And that's just going to be a better name on death plane area entered versus if we did it a different way. And now we can come in here and basically handle when a player dies. And what we can do is we can basically just go, okay, the player's dead, so we're going to snapshot their score. So $ spawn timer dot stop, and that's going to stop from spawning. $ score timer dot stop, because the player can no longer get score, they're dead. And then we're going to need to fire off some kind of game over. So we'll come up to the top and we'll create a signal for that. So I'll come in here and I'll go game over, and we don't need to pass in a score. I don't think it's really worth us doing. Or maybe we could, because then we could handle our code and segment it a little bit better. But I think actually I'm going to keep this just because it might be a bit easier to work with. So we'll say game over dot emit, and then we'll pass in our current score like that. And now we can basically handle when the player dies, because now we know, okay, the player has died, right? We've emitted this event here, which means when the player receives this event, which they're going to have to subscribe to, but when they receive this event, they know I have died. So you can come into your game manager, game over, and then you can click on the player and say on game over, or on game manager, game over. We can basically just change our state to dead. So we'll come in here and say current state is equal to state dot, and we already had a state for that, dead. Simple enough. And then if our player is dead, we can come in here into our physics process. If current state does not equal state dot dead, then we can do all of this bit of code here. Else the player can't really do anything. And that allows us to effectively stop the player from playing while they're dead. And then we can come in here when we emit that game over, and we can subscribe to it in our UI manager. So we'll come over here, double click on this guy, go down to our UI manager and hit connect. And now our game manager, or our UI manager, knows. And now our UI manager knows that our player has died. So when that happens, let's right click, add in a child node, and let's add in special instructions for that. So we'll come in here And we'll add in a control node like so. And we'll go to 2D so that way we can actually see what's going on. And we'll center align this. We'll center align it. We'll make it, I don't know, about yay big, give or take. So we'll go like that. And then we'll recenter align it. That way it's aligned properly. We'll right click, add in a child node. We're going to add in a VBox container. And we'll make that full rect so it's full sized for our screen. Then we'll right click, add in a child node. We're going to add in a button, which will allow us to have a button. We're going to right click, add in a label, put that above the button, and then we'll right click, add in a control node as a spacer here. So we'll put that in center. Now you can see here, I can come into my label, I can type game over like that. And I will put this at center alignment. And actually, I'm going to duplicate this label. So we'll duplicate, and then I will put score, colon, and then we'll set our score. We'll call this the score label. And then we'll call this the game over label. The button here is going to tell Godot to play again, like so. And then with our control node in here, what I'm going to do is I'm going to make that into a spacer. Now, this is something that I've been messing around with as time has gone on, just to see if I can get it so that way we can actually have proper UI layout methods. And I've noticed that if I just add in, space here, it will work out. So I can just do 30 pixels of space, and that just kind of gives us a nice spacer in between that. And now all I got to do is in my UI manager, when somebody dies, I just go $. This control node needs to be renamed as game over container, like that. We'll copy that. $game over container dot show, like so. $score label dot text is equal to score colon space plus, and then we'll just pass in that score. And we'll need to make it into a string like so. So that way it is a string. There we go. And that will allow us to show the player's score. Now, when you click on this button, play again, we're going to need to emit a value, right? We're going to need to say, hey, the person wants to play again. So in order to do that, we need to have a signal for that. So we'll come in here and we'll say signal start game, like so. And what that will do is that will reset everything. And that's going to allow us to have a UI right off at the bat, right off in the beginning of the game that you can click on and hit play, right? So that way you have a full game loop, if that makes sense. And now we can hook the button up to that event. So we can click on our button down, and connect that. And that's actually connected to the wrong thing. So let's disconnect that, and then let's connect it to our UI manager. And we'll come in here and go signal start game dot emit, and that will emit a start game event. And now I can take my UI manager, I will connect it to my game manager, and game manager will go ahead and actually tell everybody, hey, this button was pressed. Now you can see I have this function here. We'll go ahead and get rid of that. But when a UI manager dot start game runs, we need to basically reset everything. So I'll come up here and I'm going to create a signal, and we'll duplicate this guy, just get rid of this guy, and we'll type start game. We'll come in here, we'll go start game.emit, like so, and that's going to tell everybody to actually start the game. Now, basically, we're relaying our stuff up to our game manager and then letting our game manager handle starting the game itself. So first, we'll reset our score, and then we'll reset our speed multiplier. And we'll want to set our speed multiplier back to 0, it looks like. So we'll set that to 0. And then we will also set, if we take a look at this, I think that will work. And then we'll also hit $, score timer.start. And then we'll do $, spawn timer.start. And that'll basically reset the game. And then when we emit our start game, we can basically take our game manager and say start game and hook it to our player.
like that. And we'll also come into our game manager and do one last thing. I almost forgot. Update score updated.emit, and we'll pass in our score value like that. And that'll basically just tell our score that it's been updated back to 0, if that makes sense. And now what we'll do is we'll come into our player and we'll subscribe to that event. So you can see that we already have it right here on Game Manager Start Game. And what we'll do is we'll reset our player. So position is equal to vector 3, 0, 0, 0, like that. And then if we take a look, if there's anything else that we need to reset, our state is the next thing. So current state is equal to state.running, like that. We can double check if there's anything else that we need to do. I don't think so. I think we'll be okay. And that should give us almost a full loop for our game. So if we hit play, and you can see if I click play again, nothing happens. So that's not a great sign. But actually, let's see what happens. You can see our speed value has set to 0. So it kind of worked. Let's take a look really quick. If we go back to our game manager, what is our standard multiplier? 1.0. So that's my fault. We need to set our speed multiplier back to 1.0, which will allow it to be reset. If we hide our game over container, we let ourselves die. Let's see what happens. So I'm going to let myself die. Game over. You can see everything stops and it stops spawning enemies. We click play again and it resets us back to here. Now the screen did not disappear, so we're going to have to fix that, but it is actually working. So that's good. So we can do that and we can die and it will say game over and it shows our new score of 6. So that's exactly what we wanted. Now, if we take a look at our game over container, when the person starts that game, so if we go back here, instead of just start game.emit, let's do start game.emit $game over container dot hide. Because that way it's going to hide when we do that. And I think that should be good. We don't have anything in here to reset, so let's try that. So we'll see what our score is. So right now it's 70, 90, 106, 120, and we're dead. Score is 120. We'll hit play again. Score is now 0. We'll crouch. Score of 12, score of 14, and then we'll go ahead and die. Score of 20, game over. Perfect. So now we have some kind of loop, right? We can play the game, we can run through, and we can actually continue playing our game. We do need to come up with a way to start our game, and that will be really easy. If we just come in here, add in a new control node, we go into our 2D scene, let's center align this, and let's make it about, I don't know, about this big, give or take. And actually, to make it a little bit easier, let's add a panel. So let's make this a panel, like so, and then let's do that as a full rect. And that's just going to make it so we can actually see what's going on here. And then we can right click our panel, add in a child node, and let's add in a V box container. Let's make that a full rect like that. We'll right click, add in a child node, we'll add in a label, and inside the label, we'll just say endless runner tutorial, and we'll set that to a center alignment like that. And then I'll right click, add a child node, add in a control node, and add in a button. And we'll say start game like that. We'll grab our control node and then we'll make that layout a custom mini size so that way it actually fits inside of our little container here. Now, what we could do is we could duplicate this label actually if we wanted to, adjust this down so that way it matches properly, something like that. And then we can come in here and say, right arrow to go right, left arrow to go left, down arrow to slide, and space to jump. Now, that's just me coming up with some kind of wording here so that way we can actually see, so the user knows how this stuff actually works. And then we can come in here and change the theme here. So we'll override the theme and we'll change this to be slightly larger. So we'll override it, make it something like 15 or maybe 30. That's way too big. So we'll do something like 26. That's still too big. So I'm going to just kind of flick it like this. And there we go. That'll just give us a little bit of buffer there. It'll look a little bit nicer. And there we go. And that's simple enough. Now, we're going to make this hide when the player starts the game. So we'll do start game container, and then we'll do this. We'll come up here, and when the user starts the game, we'll attach it to the same exact thing. So we'll do button down, and we'll connect that to our UI manager. And you'll see that that connected to our on button down. So that should just work. And we also will need to hit $ start game container .hide. Well, and there we go. And that will basically allow us to have a start game container, and you'll see start game will admit. So what we can do now is we can set our player's default state now from alive to dead. And the reason why is because if the player starts off dead, then we should be okay. If we hit play, you'll see endless runner tutorial. Things are spawning. Don't worry about that. We'll solve that in a second. But then we can hit start game, and the game will start like so. Awesome. And then when we die, it'll say game over, and we can play again. Now, of course, I'm going to adjust my game over container real quick to add in a full rect panel because we definitely need it. Doesn't look very good. So we'll do that, and that will allow it to actually look reasonable. You can see right here. Now it's got a darker panel here, so that should help. And finally, we're going to need to go into our game manager here. We're going to need to tell our game manager to only spawn if the game is playing. So we'll say, so instead of doing it in here, which is what I was thinking about doing, I'm just going to grab these two guys and I'm not going to auto start them. So we'll just click those guys and that will tell them to stop. And then that way the death plane stuff will be right. When we hit the start game, it will start the game and we should be good to go. So if we hit play, you'll see that nothing happens and the player cannot be controlled. I can hit spacebar, left, right. It doesn't really do anything. Only when I click play does the game allow you to play. And then when you die, so we'll let myself die, the game stops and all of the spawning stops. Now you can see that this panel is over top of everything. So we'll just adjust that really quick by grabbing our panel, dragging it to the top, and then there we go. Now we can see what we're doing. And then if we click play again, you'll see that we are now in the game. And I'm very poor at my own game, but that's okay. And there we go. So now the question is, okay, how can I handle leaderboards? How can I handle that kind of stuff? So first thing we'll need to do is we'll need to actually create our leaderboard. So I'm going to open up our game over container here, and I'm going to come in here, hide our start game container, and I'm going to right click, add a child node, and I'm going to add in a panel. And we're going to bring this panel over here onto the right. And really, I'm thinking we can actually just pull this out instead. That way we can handle this. So we'll say leaderboard. Like so, we'll right click add a child node, and we're going to go and add in a VBox container like so, and we're going to make that full rect like so. And then I will come in here and have a title attached to this as well. So we'll right click our VBox container. We'll come in here and add in a label, and I'm just going to call this leaderboard. And then we'll go ahead and make this center aligned. Now the leaderboard is going to allow us to actually have some form of leaderboard so the user can see who actually is doing good, right? Who's been successful, who has not been successful. So what we'll do is we'll come in here, click on UI manager. We'll come up here and we'll keep track of all of that.
So in order to do that, first we need to make an array of scores. So we'll say var I scores. We'll make that equal to bracket bracket, because then it's going to be an array. Now you could have also type it as well if you would like to. Then we're going to come in here and say at export var max leaderboard entries, and I'm going to make that something small, like 10. I'm going to make that a type int. That way we can keep track of that. And now we can come in here and actually keep track, add stuff to that array. So we'll come down here, and where we have our score text, so right here when we do our game over, we can come in here and basically add stuff to our high score. So when we want to add this to our high score, we can go high scores dot append, and we can pass in that score value right there. And then we can sort it. So we want to make it so that it's all in a proper order. If I have a value, let's say somebody gets a 1, somebody gets 2, somebody gets 5, somebody gets 2, and somebody gets 15. We want to sort this so it's in the proper order. 1, 2, 2, 5, 15. But now we want our score to be 15, right? 5, 2, 2, 1, right? Because we want the highest score first. So in order to do that, we need to first sort it. So highscores.sort. And then we need to reverse that sort. So highscores.reverse. And then we can basically rip out any scores that we don't care about. So if high scores dot size is greater than our max leaderboard entries, then we can just resize it. And we can pass in our max leaderboard entry like that. And that basically allows us to keep our array at the right size. So our array will never get higher than 10, than this max leaderboard entries right here. And that's going to allow us to keep our array nice and small, so it's easier to work with. And now we need to update our leaderboard display. So in order to do that, we first need to clear out our leaderboard stuff. And in order to do that, so in order to add stuff to our leaderboard, we'll just say for I in range highscores.size, then we can actually go ahead and add in a new entry. So what I'll do is I'll say var entry is equal to a label dot new. And then I can go entry dot text is equal to %d dot %d. Then we'll go modulus bracket I plus 1, comma, I scores bracket I. And the reason why I'm doing this is I'm going to show you guys a different way to approach this. So something that you can do in Godot is a built-in string replacement. So instead of how I'm doing it up here, you can actually just do %d, and then it'll take the first element, and then %d, and it'll take the second element. So this will show number, period, the high score. So that's just something to keep in mind. It's not, some people like it, some people don't. So I try to avoid it if I can, and we'll add parentheses on here so we can fix that error. But I wanted to show you both ways so you guys can decide which one's best for you. And now I'll go $leaderboard VBox container dot add child entry. And that'll add in our scores. And then we want to kind of highlight, right, the one that is the victory, if that makes sense, right? The one that's the best. Now, what we could do, now that I'm thinking about it, is change this from a label to a rich text label instead. And if it's a rich text label, then you take a look at it. You can see it has BB code. So you could actually enable BB code. So entry.bb code enabled is equal to true. And then you could say if I is equal to 0, then we could actually change this text here to bracket bold. If I remember correctly, it's bold. I'll double check really quick. So let's do test. That way we can see our test text here, providing that it's proper sized. If I take a look at my VBox container, this might be a slight problem. Let's make it proper sized. And then I believe BB code is bold. It's B. So we'll do that. So the person that wins gets the B tag attached to it. So we'll do B, and then we'll do that. That way, they get a bolded version of their name. So that way they know that they are the best. So then we can delete this, and that should work, hopefully. So now let's come in here. And now we need to basically come in here and show our leaderboard. So $ leaderboard dot show, like so. And then whenever you start the game, we're going to hide that leaderboard. There we go. And now when a player starts the game, they should see it. So we can go like this, hit play. You'll see the leaderboard, hit play. It will show the thing. If the player dies, it says score 10. Our leaderboard did not get updated. So that's not a good sign, but my guess is it has to do with the settings on the VBox container, because the VBox container is, I think, clipping our leaderboard here. And in order to do that, what I'm going to do, even though because I'm not quite sure how I can handle this, so I'm going to go with entry dot custom minimum size is equal to a vector2, and I'll make that equal to something like, if we add one here, like so, and we type test, and we change this to be, let's see, custom minimum size. If we go under layout and we set the Y value to something like, looks like 25 is going to be the value we're looking for. So I'll trash that, come in here, set this to 0,25. And I'm not a huge fan of this, but it's probably the best route that I can think about doing it right now. And we'll go like this, hit go, space, and then let myself die. And there we go, 179. Perfect. And if I hit play again, we'll let myself die. 7941. So you'll notice that we have duplicates here. So why do we have duplicates? Well, if we look at our remote here and we open this guy up, we open up our UI manager and we open up our leaderboard, you'll notice that we have 3 rich text labels here. See that? We need to go through and actually delete our old leaderboard and then reinitialize it. So let's do that really quick. So for I in range iscores.size. So what we'll do is we'll say for child in $ leaderboard VBox container dot get children colon, and then we'll basically check if the name does not equal quote label, because you can see there's a rich text label versus label. So label colon, then child.q free. And in theory, that should fix our problem. So we'll do that. We'll hit play. You can see that we have our game over pop up. Don't worry about that. We'll fix that in a second. So you'll see I have 141, dead, play again, dead, 2. Perfect. And then if I play again, you can see I'm getting a few more scores. We'll let ourselves go until this guy comes up here and we're dead. 150. So you can see that we've beaten the score. Awesome. So now the question is, if we hit refresh, the game deletes our leaderboard. And we don't want that, right? We don't want our game to actually delete our leaderboard every time we play, because this is a leaderboard, right? This is an arcade game. So we want you to have that forever. So what can we do? Well, we can save that leaderboard. So I'm going to create a function for that. So func save leaderboard, like that. And in order to save our leaderboard, it's actually going to be really, really easy. All we'll do is we'll come in here and we'll say var file is equal to file access.open, and then we'll come up with some kind of file. So we can make this whatever we would like. But in my case, I'm going to come up here and I will make an exported variable for this. So that way In my case, I'll come up here and I'll make a const for this. We'll say const save file is equal to :string, and we'll make that equal to user : //highscores.save. Now, you don't have to use .save. You can use whatever value you want. But in my case, I'm going to use save because that's a pretty easy way to have a somewhat obscured file so that users have to go through one more step. If you see a .save file, Windows will not immediately tell you that it is a text file that you can edit. If it's a .save, Windows doesn't know what the file type is, so it makes it just a touch bit harder. You have to copy it into Notepad anyway and edit it, but it just makes it a little bit more obscure so the user doesn't know exactly what that is. So we'll scroll down here and we'll go File, Access, Open, and when we do that, we're going to come in and do save file, comma, file access dot write. If file, then we'll go file dot store string, and then we'll say JSON dot stringify, and we'll just pass in our high scores like that. And then we'll close that file. And that's going to effectively save our data. So let me pull this open a tiny bit so we can actually see a little bit better. So all this does is it opens up a file in our user directory and just saves it. Very simple. And then we can just say else print quote error could not save high score. That way, just in case for some reason if something goes wrong, we can keep track of that. And now we want to save our leaderboard. So if we go into our thing here, save leaderboard, and that'll basically, anytime we get a game over, it automatically saves the leaderboard as soon as it appends it. And that should be pretty easy. So if we do this, we hit play. In theory, we should see if I die, no errors. So that's good. If we stop the game, we go into project, open user data folder, you'll see that there is a highscore.save file. If I open that up with text edit, you'll see that it has a 10 there. That's perfect. That's exactly what we wanted. That is our saved score. So we can come in here and now load that value. So first things first, we'll create a function to load that value. So func load leaderboard, and then we'll come in here and say basically exactly what we have here. So I'm going to, grab this guy, duplicate it, but do read instead of write because we want to read the file. And then if file high scores is equal to json.parse string file.get as text, and then file.close. And then we can do else print quote error colon could not read high score, like that. And we're going to want to now read that high score. So let's go up here and let's create a ready function for that. So we'll say func underscore ready, like that. And we'll say load leaderboard, like that. And that will load our leaderboard. Now, something that we're going to have to take a look at, right, is when the user, you'll see I'm changing my game over to start game, so that way we can have our start game scene. You'll notice that our leaderboard, if we hit play, doesn't get populated. So why is that? Even though we are loading our leaderboard, we didn't get any errors, see? So what happened? Well, we need to tell our leaderboard to update. So I'm going to grab this bit of code here. I'm going to Control X, and I'm going to separate that out. And we'll paste it like that. Now, this probably is going to require me to pull in a value. So if we'll take a look at it, high scores high scores append. Actually, that looks like it should just work fine. So we'll do update leaderboard, and there we go. And that's basically just going to allow us to update our leaderboard at will instead. We'll pull this guy up and we'll do load leaderboard, and then update leaderboard. And now if we hit play, you'll notice that it loads our leaderboard properly. And then if we hit play, let's get slightly higher than 10 this time. So we got 28, crouch under this, jump, and then I'll die at 103. You'll see, or 105. So you'll see we have 105. I refresh my game and you'll see the leaderboard says 105. So that is basically how you create a very basic endless runner inside of Godot. So if you like this video, go ahead and hit that like button. Hey, you know, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested. So, you know, if you have any suggestions, please leave them in the comments below and I'll be more than happy to look at them. I'm currently still doing WWISC integration as a tutorial, and I have some AI stuff I'm looking at because nowadays AI is starting to become more prevalent, so it's always a good idea to stay on top of that. So if you have any suggestions, please always let me know because that's how I build my videos. And hey, you know, if you have any questions or comments about this tutorial, if you want to have any, if you have any issues or anything like that, or you want to tell me that I'm doing a poor job, please leave a comment below or jump on my Discord. Links in the description for that. And anyone there will be more than happy to help you out. But that is all I have for you guys today. So thank you so much again for watching. And I will see you all next time. Thanks.